Suppose you have two functions with you. One is f of x, which is equal to x square plus 1, and the other one g of x minus 3. You are asked to find f of f composition g of x. This 0 stands for composition, f composition g of x, and g composition f of x. So how will you find that? See, this f composition g of x means f of g of x. That's the meaning of f composition g of x, that is f of g of x. But you have f of x is equal to x square plus 1. Now you need to find f of g of x. If here it is x, then it is x square plus 1. So what about if inside the braces it is g of x? Then it is g of x whole square plus 1. The function f of x is defined in that way, x square plus 1. So whatever be the inside the bracket, whatever be inside the braces of f, it gets squared and added by 1. So g of x whole square plus 1. And now you know g of x is equal to x minus 3. So this is equal to x minus 3 whole square plus 1. On expanding, you can expand this using the identity a minus b whole square, which will give you x square minus 6x plus 9 and this 1. This is equal to x square minus 6x plus 10. X square plus 6x plus 10. So that is your f composition g of x. Now see, now what about g composition f of x? See, g composition f of x, which means g of f of x. See, your g of x is defined in this way, x minus 3. If here it is x, then this will be x. So what about g of f of x? So in place of x you have to put f of x. So f of x minus 3. But f of x is equal to x square plus 1. So x square plus 1 minus 3, which will give you x square minus 2. So g composition f of x is equal to x square minus 2. See, this one is x square minus 2, and here it is x square minus 6, x plus 10. Clearly you'll get f composition g of x not equal to g composition of f of x, which indicates the composition of functions are not commutative. You get different answers if you go in one way, and you get a different answer if you go the other way.